Okay, lesson 18. Are we there? We're there. Okay, so lesson 18 is taking us back to some function review, some function rules, and just lots of different things with functions. So, starting off looking at some basic rules here. Sums, differences, products, and quotients of functions. So the idea that if it asks you to do f plus g of x, that means you're taking f of x and adding g of x. If it asks you to find f minus g of x, that means you're asked fg. You take f, multiply by g, obviously f over g. It's just dividing the functions. Okay, so if they show it there together in one parentheses, it's the same as doing it individually. So we're going to go through a run through here. If f of x is x squared and g of x is the square root of x, find whatever they ask us. And we're also going to talk about the domain on each of these. So, I don't think I dated my notes. I always date my notes.
It's like 50-50.
I try and always date them just so if someone, comes a week later and says, well, I was absent this day, and, I can figure out what notes we did, but. Okay, so A is asking us to do f plus g of x.
F of x plus dx.
And what is f of x? X squared
And g of x is
plus what's g of x? Square root of x. Does that simplify? X squared plus square root of x is just x squared plus square root of x. So we are done right there on that behalf. But we're also being asked to find the domain. Thoughts on the domain for f plus g?
X has to be positive.
Why would x have to be positive?
X plus 4 because it can't be negative. That is x squared.
Okay, so right here, there's a radical. Whatever's under that radical has to be not negative, was the final decision I think Daryl came up with. So greater than or equal to 0. Are there any restrictions on the x squared? No, you can square anything you want. So, what is our domain? X greater than or equal to 0. Now, a couple of different ways you can write that. If we use the fancy notation, it's a brace. X is a member of the reals such that x is greater than or equal to 0. The other option is interval notation. What is interval notation?
Bracket 0 to infinity.
Okay, so interval notation would be a bracket 0 to infinity with parenthesis. Okay. B, what's f minus g of x?
X squared minus square root of x.
Okay, pretty much the same, except it's x squared minus the square root of x. If the last one didn't clean up, guess what?
This one might be clean up.
This one won't clean up. What about the domain? Same thing? I never do this, guys, but guess what? I'm going to take this easy route. Same.
Oh.
Did you already start rewriting it?
Yeah.
You can finish rewriting it. That's fine. I was just actually taking the easy route. Usually it's you guys that want to take the easy route out, but
I probably just draw error.
okay. Fg of x.
Fx gx would be x squared times square root of x.
X squared times square root of x. Can that be cleaned up?
Yeah.
Thoughts on how to clean it up?
Change the square root to raise to the half.
Okay, so the square root of x is the same as saying x to the 1/2. Sound familiar?
Yeah.
And what is x squared times x to the 1/2? When you're multiplying with like bases, you add the exponents. 2 plus 1/2 is 5/2. So I'm going to rewrite this as x to the 5/2. What about the domain? Still can't be negative based on the original part, right? Okay, and based on this, I mean, this is the square root of x raised to the 5th power. So because we have that denominator of 2, I'm going to cheat again. Same. Not cheating, I'm just taking the shortcut route out is what I'm doing, I guess. Okay, D, f over g of x.
X squared over square root of x.
Okay, so x squared divided by square root of x. Clean up. Okay, we can't leave a radical in the denominator, so we can rationalize by multiplying by square root of x. I just thought of another way we could have done this. Oh well. We'll get there. So, when we multiply on top, like earlier, this is going to be x squared square root of x. What is square root of x times square root of x? X. Could you go one more step there? Okay, we can make them all to powers, which I was actually going to do that afterwards. What can happen with an x right here is what the direction I was going. An x could cancel. Now, if Daryl makes them all powers, realize whichever direction we go, we're going to meet in the end here. Okay, so there's multiple different directions. So if you cancel an x, this now becomes x square root of x. But what's another way to write x square root of x in terms of powers? X to the first times x to the half, which is x to the 3/2. I have both of these boxed on here. It just depends what form you're being asked. I had an aha moment in the middle of this problem. Kind of kicking myself. And I guess it depends how you're expressing your answer. If you're expressing your answer with a radical, we needed to go the way we did and rationalize. If you're going to express your answer with a power, we could have right here changed to powers and just subtracted. X squared divided by square root of x, which is x to the 1/2. 2 minus 1/2 is 1.5 or 3/2. So many different ways you could get to a final answer on that problem. So, okay, domain. Not quite is my response to the same. What do you mean just greater than 0? Okay, so if we go back and look at and this is where you can't just look at your answer when you're trying to figure out the domain. When you would have plugged this in originally, realize there's a radical, and a radical normally we say greater than or equal to 0, except when that radical's in the denominator. And so then instead I'm going to say x greater than 0. So it is oh so close to the same, but a serious difference there. So we can either write x is a member of the reals such that x is greater than 0, or interval notation. parentheses 0 to infinity.
Beautiful.
Okay. Questions there? Moving along then. Mallory said she wanted to talk about fog. So here we go.
I did not like it.
You don't like fog?
I wasn't here last year today we learned it, so I never really got it.
Ah, okay.
Can we do this on the names left in the folder about hole?
I don't remember what day it was we learned it, but I remember not being here for it.
I feel like we would have possibly done it in Algebra 2 as well.
I think I did it now.
You might have even done it in Algebra 1.
No,
But I feel like I thought you would have done it in Algebra 1, and then everyone gave me that deer in the headlight look like, no, we didn't talk about
I
this.
don't
So,
think we really did anything in Algebra 1.
so Algebra 2 is when I think I introduced this in Algebra 2. So, okay. So, what is lovingly referred to as fog here? Composition of functions. So, f composed with g of x can be rewritten as f of g of x. Okay, and the idea here is when you're doing f of g of x, since g of x is the inside, you take whatever g of x is and plug it into f of x. So let's look at this first example. Using the functions, f of x is x squared plus 2, g of x is 3x plus 5, form the composite function fog. And then we'll talk domain. So, first of all, it's a composite dot, so you do understand that this is not multiplying, yes? So, fog, f composed with g of x, I always start off by rewriting it as f of g of x. So, what is my inside function? Inside function is g. So I'm going to take whatever g is, and I'm going to plug it into f. So what is g? 3x plus 5. I'm going to take that 3x plus 5 and plug it into f. Where does it go in f? In place of the x. So since f says x squared plus 2, I'm going to do x squared, but my new, instead of x, I'm going to write 3x plus 5 squared plus 2. So I took the f, which was x squared plus 2, and I replaced the insides with g, 3x plus 5. Depending on the situation, depends whether you get to leave it or you have to go farther. How do we do 3x plus 5 quantity squared? FOIL. So 3x times 3x is going to be 9x squared. Outsides and insides, 15x and 15x, which is 30x. Last, 25. Plus the other 2, if you would, 27. So this is what f of g of x works out to be. It did also ask me to state the domain. When looking at domain, always go back to f and g. Don't just look at what fog was. Look at f and g. Restrictions on f and g. No radicals. No denominators. Nothing to worry about. I mean, those are the 2 things to watch for. So, if there's nothing to worry about, what's my domain? All reals. That can be written as the fancy R that indicates reals. Or, what is that in interval notation? Negative infinity to positive infinity. Okay, you ready for example 3? We get new functions this time. F of x and g of x are new, and it says to find f of g of x, which basically if they're asking me to find f of g of x, what are they basically asking me to find? That's fog. It just isn't stated as fog this time. Okay, can you do it? G into F. So my F is 2 plus sine of x. Except what is my new x? Whatever g is, which is x minus pi over 2. So I now have 2 plus sine of x minus pi over 2. Not quite. Okay, so I don't know if you guys heard Daryl. He said 2 plus cosine x. He's on the right track. What is he connecting here? The cofunction identity. Now, if you precisely look up the cofunction identity, the cofunction identity states the sine of pi over 2 minus x is equal to cosine of x. That's what the cofunction identity states. So what's the slight adjustment here? It's reversed. So when it's reversed, you can basically factor out a negative here and put it out in front of sine is what can happen. So if I take the negative out, it changes those signs in the parentheses. And so now this can be written as 2 minus the sign of, instead of positive x, it's negative x. Instead of minus pi over 2, it's plus pi over 2, which, for form's sake, I'm going to reverse as pi over 2 minus x. So when Daryl said 2 plus cosine of x, I just need him to adjust and say 2 minus cosine of x. Good call, though. The struggle right there is, could you at least recognize that, oh, that's like that cofunction identity? And that's half the battle right there, is being able to oh, that sounds familiar, what is that? And you just have to remember that pi over 2 or 90 comes first. A common trick they'll do is they'll give it to you as x minus pi over 2, so you have to recognize that it's just different by a negative. Example 4. The function e to the negative 2x plus 1 is a composite function. Use two function machines to show how it could be composed. Basically, if we call this f of g of x, what's f, what's g? That's the short of what this question is asking. So, if I call this f of g of x is equal to e to the negative 2x plus 1. And I have to specify that's f of g of x because it can make a difference of what works. And I want to know, what could I use as f of x and what could I use as g of x to make this composition? Play around with it some, see if you can come up with something. What do you think, Logan? I like it. If f of x is e to the x, then what's g of x? Negative 2x plus 1. Put it back together in your head. Does that work? Yeah, because you're taking g and you're putting it into f. So you're putting it in place of that x. Now, are there other variations that could probably work? Yes. That's the most obvious one, though. And thus the easiest one to come up with. Let's do the same thing again. This time my function is sine of 2x plus 3. Function machines. So again, I'm going to call this f of g of x is sine of 2x plus 3. If that's the case, then what would you like to use for f of x? What would you like to use for g of x?
F of x, sin x.
You guys okay with that? I can agree that f could be sine of x, and then that makes g of x 2x plus 3. Again, we could probably find other more complicated ways to make this work, but that's the easy route. Okay, example 6. We got f and an x, and we're asked to find domain of fog and domain of Goff. Now, when we talk about domain of fog, domain and range of fog and Goff, first of all, you do need to look at f and g individually, but you do also need to look at what fog is and what Goff is, because that could affect your domain and range. Not guaranteed, but it could. So, what is fog going to look like? It's f of g of x, which what is f of g of x here? Square root of 2x plus 3. Okay. Let's talk domain.
What can be negative? Well, actually,
What can't be negative is the question here. Everything under the radical can't be negative. And so take whatever's under the radical, which in this case is 2x plus 3, and set it what? Greater than or equal to 0. Because it has to be non-negative. Now, if you solve that, subtract 3, divide by 2, x has to be greater than or equal to negative 3/2. Any other restrictions? Nope. So there's your domain. And I'm just writing it like that. I'm not getting fancy. Okay, range. We haven't really talked about range today. Domain are your x values. Range are the y values. With y. What did I just say?
Y value.
No, I said y out values. I combined the word output and values. Something else was, I was a step ahead in my mind, and the word output was going through my mind. It just came out my filter also. Okay, so the y values, or in other words, the output values, have to be, that's what we're trying to do for range, yes? So when you look at the output of the square root of 2x plus 3, what kind of values have to come out of the square root of 2x plus 3? Positive values, yes? Because we know the idea that any square root has to be greater than or equal to 0, yes? It doesn't really matter what's under the square root here, but that square root is the whole function. Since that square root is that whole function, the square root has to be greater than or equal to 0, then those are my y values. Because if you look up here, y is the name for f of g of x, isn't it? F of g of x are my y values, so this square root is y. So since it's a square root, my outputs have to be positive. Okay, Goff? Goff is g of f of x. What does g of f of x look like? Okay. 2 square root of x plus 3. Domain. Domain should be fairly easy to figure out here. What? Yeah. My radical again has to be positive. What's under the radical this time though? Just x. So x greater than or equal to 0. No denominators to worry about, so it's just x greater than or equal to 0. Range. So range, the output values of the whole thing. Think about the output values of the whole thing. Okay. Y greater than or equal to 3. I agree. Because what do we know about this radical here? That radical has to be positive. So even if that radical is 0, it has to be greater than or equal to 0, yes. And then you add 3, then it's going to have to be 3 or bigger. So it's the idea that you have to think about it's a radical plus 3. That radical is 0 or larger. So when you add 3, I agree. Y greater than or equal to 3. Okay, last one. Determine whether the following statement is true or false and explain why. If f of x is x squared, g of x is square root of x, then the domains of Fogg and Goff are equal. Oh, excuse me. So we should probably figure out what Fogg and Goff what happens with Fogg and Goff. So Fogg, f of g of x. What does f of g of x mean? The square root of x, quantity squared. Technically, what does the square root of x squared simplify to be? X. Okay? We'll come back and talk about the domain here in a moment. Let's look at Goff. Goff means g of f of x. What's g of f of x look like here? The square root of x squared. What is the square root of x squared? X. So, interesting enough, Fogg and Goff both result in x. If we just look at the fact that Fogg and Goff are x, what is our domain? All reals, because x can be anything, yes? However, you know there's a but here. How did we get each of these? So, if we look at Fogg, how did we get that x? What did we put in here? It was the square root of x squared. Are there any restrictions here? This x right here has to be greater than or equal to 0 because it came out of it was under a radical. So can we use just any x we want in FOG? No. Now, what about Goff?
Numbers, because anything can be squared. Negative number can be squared.
When we do Goff, we put a number in. The first thing we're going to do is we're going to square it. Anytime you square something, it's going to become a positive. And then will I be able to take the square root? Sure. So in this case, all reals. So, was this a true or false statement? False. I know you're so surprised to see that, right? You kind of saw it coming, I'm guessing. False.
Explain why.
Well, what do we decide? FOG uses only x values, x greater than or equal to 0. Goff uses x values that are all reals. Thank you. Okay. Questions on lesson 18? Big old function review there, yes?